this video, we will move forward from the challenges of urbanization and elaborate on the challenge of socio-economic change and the principle of equity and the human perspective in sustainable development. Today, all metropolitan areas worldwide face the same question: how to ensure a high quality of urban life and the sustainability and resilience of our vital systems. Although many roads lead to Rome, most urban-centric positions to achieve real advances in quality of life are based on responses to socio-economic change and the human perspective. This can be either from the perspective of sustainability, here framed as the sustainable city, to make sure our children inherit a world at least as healthy, beautiful and with similar or better opportunities than we have ourselves, or improved equity and government transparency, also framed as the just city, or by a focus of quality of life, framed as the healthy city. But in all these positions, increasingly the perspective of technology comes in as well, and how this relates to us humans and our social, economical dependencies and organization. This raises, of course, all kinds of questions, including seemingly funny ones, like how do you tip a robot bartender? But seriously, regarding metropolitan challenges, in general, technology is used to help achieve efficiency improvements. For instance, to achieve efficient infrastructure and resource use. An aim often connected to the concept of smart cities, which will be elaborated further in the context of digitization in week 6. Meanwhile, cities are constantly being ranked for their livability, their happiness, cultural capital and creativity. However, it results that it is constant innovation that stands out as the key stimulus for longevity in economic competitiveness. So, where some cities have gained recognition in innovation through short-term booms, such as Helsinki and Dubai City, the more dominant global cities like Singapore and London, or Paris and New York, have maintained high levels of innovation and retained their prominence over time. This is why several studies have suggested that the key characteristic of leading world cities is that they should focus on innovation and attracting the best and brightest minds, or as I name them, Crobos, new generations of creative and hobo, or mobile creative talent. Talent that hops around the world in search of new exciting places to live and work. So to come back on the different urban positions, this aim to achieve increased levels of technical innovation and urban dynamics in the end is central in finding solutions to social economic change. This is often named the innovative city, the smart city or the creative city. There are, however, important, if not more important, social aspects as well to consider. The most pressing urban problems are not technological, but social in nature, and have tended to be exacerbated, not solved by corporate-led privatization and city branding strategies. As by mid-century, 2 billion people in developing countries will be living in informal settlements. This is also connected to what is called capital-biased technical change, where urban poor have less access to and opportunities for technology and progress caused by technical innovations. And thus they have less opportunities to a better future. This is why the challenges related to socio-economic change should include the perspective from both formal as well as informal urban areas, and how informal developments and people can be supported to empower, transform and improve their living environments. With such an informal growth context, it is important to be aware that humans have a fundamental right to certain facilities, as it is called the right to the city, as Henry Lefebvre framed it, and which could be specified into the right to access and infrastructure. And it relates to the lack of some basic services like, for instance, sewerage and clean water, which still in many parts of developing metropolitan regions in the world is the case. While in these regions it is here that the brunt of urban growth is taking place, as we saw also in last week's challenge of urbanization. And to make it even more crucial, often these extensions are located at the most vulnerable places in cities, like on slopes, subject to landslides, or in deltas, subject to flooding. Events that are expected to happen more frequently the coming years, due to climate change, which is the challenge that will be addressed next week. Another important notion is the following. Although we are using technology to find solutions for many things, we often don't seem to think about whether and how people will embrace these solutions, and how dependent and resilient it makes them. Humans adapt their behavior, and that can have either negative or positive effects to the way we organize and run our daily lives and urban environments. This is also specified by sociological facts that humans are malleable and conditioned by their social environment, not the natural environment. The negative side of this concept is that people do not act as we could expect them to do. Like for instance, in the Dutch city of Amersfoort, where a new solar-based zero-energy urban neighborhood of several hundreds of houses in the district of Nieuwland was realized. Once people started living there, it resulted not to be at all energy neutral anymore. After investigating the case, it resulted that besides of several technological problems, people also used too much energy, as they thought that as energy was generated by renewables, they could use as much as they want, which of course was not always and entirely the case. But there's also a positive side to this concept, as it also means that people can be educated, that they can change in a positive way, preferably together and preferably by involving them as much as possible and by including so-called feedback loops in the solutions you design for them. For this, two levels of skill are crucial. The first is the scale of the neighborhood, or the local living area, where solutions meet users as well as actual spatial integration aspects. The second scale is that of the urban area of the larger city or so-called metropolitan region, including its hinterland and connecting infrastructures. As it is often in these hinterlands that cities need to find their resources and space, for instance to cope with their wastes or to generate their energy. Related to this aspect of scale and scope of socio-economic change is that developments are too often viewed uniquely from an urban-centered perspective, implying that anything outside is seen as rural and excluded or considered less relevant. But the city cannot exist without its hinterland, and, as stated before, most of the times cities are crucially dependent on this in-between so-called peri-urban areas, as these are key to provide resources, to help improve their climate and to provide space for mobility, recreation and much more. This dependency of cities to their hinterlands is often stronger than experienced or expected. In the early 19th of the previous century, Wackernagel and Ries introduced a method to translate and calculate this into space. Space necessary for all activities of life. It is called the ecological footprint. This method visualizes well the misfit between available space and dependency of space and related activities, products and services of a certain entity. At the moment, our global ecological footprint, as you can see, is much larger than the actual global planet can sustain. It's approximately 1.8 times the amount of surface available on our planet. In week 5, you will learn to do such a calculation of the ecological footprint for your own geographical context. So we use more than there is available. This overconsumption is possible because of inherited resources. Resources like fossil fuel, fertile land, clean water and even oxygen in the atmosphere. The act of converting renewable resources into waste faster than waste can be turned back into resources is termed global ecological overshoot. Unfortunately, this is only expected to grow further due to urbanization and more resource-intensive lifestyles. In the world map, based upon all the countries' ecological footprint, shown here, you can see how unequal our world still is. And the same holds for cities. Take for instance the city of Hong Kong, which requires no less than 2,200 times its own surface area in order to sustain itself. Of course, this doesn't just concern the direct hinterland. Due to globalization, it concerns dependencies all around the world. Actually, this involves even claims, often even literal land grabbing in weaker economies, like shown here in this graph of the countries that literally bought most land outside their own borders, the open circles, and countries that are invaded the most by such land grabbers, here the filled circles. In this graph, the size of these circles indicates the amount of surface. The same holds for cities on different scales, as cities do not stand alone. They are connected with their hinterlands and with the rest of the world. And also this holds for citizens, and for both social as well as economic relations. But it also relates to the different spatial or infrastructural domains in cities, like for instance wastewater treatment and energy, or food and waste. These interdependencies, or as I prefer to call them reciprocities, are key to solutions that address the challenge of socio-economic change. Therefore, to wrap up this introductory video to this week's challenge of socio-economic change, it is important to be aware of conditionality. Any form of sustainable urbanism is dependent on the presence of sustainable technical and ecological systems. And such systems on their turn are dependent on socio-economical balances, which on its turn is dependent on sustainable users or citizens. Therefore, metropolitan areas based upon the principle of sustainability is predicated on the need to foster a new ethos that values community building and the empowerment of the individual at both local and global scales. And to do so, and to address socio-economic change, we must look beyond connectivity based solely on technology, transportation and trade, towards finding integrated solutions at smaller scales and including their surrounding hinterlands, their communities and the bounds of the natural environment, towards the promotion of a dynamic equilibrium that will continuously adapt and transform our metropolitan areas. In this week's further videos, this will be addressed step by step based on the core themes within this MOOC.